In today's episode, we learn about ions because, we weren't happy enough, so we thought that maybe we would try that. Often, whenever parents ask about ions, they know that they're important, they know the kids need to learn them, but they don't exactly know how to help them. So this is, I often tell the parents that there are tricks, and so today I'm going to enumerate a few of these tricks. I won't do them all in one show, that would be a little bit overwhelming, but we will go ahead and get started with the introduction to ions. First of all, there are many ions, but in this class we only deal with 71 of them. So I have a sheet. You can't see the whole sheet here, but if I push it up a little bit, you can see. I'm going to go back down. You can see that the sheet is divided up into 13 sections. Section 1, 2, 3, 4, 5, 6, and so on. And what will happen is every week we'll have an ion quiz. The first week we'll have an ion quiz over the first section, which will only have 7 questions. The second week we'll have an ion quiz over the second section, which will have 12 questions. Now there are only 7 ions there, so 5 of them could come from this section. The third week there will be 12 questions that cover this section and any from these two, and so on and so forth. So by this week, you know that those 5 in the 8th week are going to be covered, but the other 7 could be any of these. So it is cumulative. You do have to learn them, and you cannot only focus on the ones that you're doing this week. So what we'll do, we'll start out by introducing you to what an ion is. An ion is an atom or a group of atoms that have a charge. That's the important thing. Being charged is what makes it an ion. A charge means that, think about like a balloon rubbing a sticky balloon on your head and it starts sticking to the wall. That's because it's charged. Any atom or group of atoms that has that property, has that sort of static electricity, it will interact with another magnetic field or with an electric field. We say that it's charged. And so charges can be positive or they can be negative. Any ion with a positive charge is called a cation, which is easy to remember. And any ion with a negative charge is an anion. Always look at the middle of the word. The middle of the word for cation has that plus in it, so it's plus ions. The middle of the word here has N for negative. So anions are negative. So if you look on here, selenide would be a negative ion or an anion, whereas strontium would be a positive ion or a cation. Every ion is composed of a chemical symbol and perhaps some subscripts and then a charge. So let me kind of walk you through that. Here we have a chemical symbol NO2. What NO2 means, that subscript denotes how many of the oxygen atoms there are. So I guess I should take a step back. Every capital letter that you see within an ion formula represents a kind of atom. So here, that is a capital C and a lowercase l, so there's just one kind of atom there, and it's a chlorine atom. Whereas here there are, again, one capital, one lowercase, that's one atom. But here, for cyanide, you'll see that we have 2 different capital letters. That one stands for carbon, and that one stands for nitrogen. So you got to be really careful because CO would be carbon and oxygen, but CO would be cobalt. So you got to be careful about capitalization. Every element has exactly one capital letter in its formula. So if we go up here, let's look at dichromate. Dichromate has Cr2O7 -2. What does that mean? Well, these subscripts mean that there are 2 of whatever comes before it, or 7 of whatever comes before it. So if we were to draw this, we would draw 2 chromium atoms and 7 oxygen atoms, and I don't care how they're arranged for now. They don't have to draw them on their ion quizzes, by the way. I'm just kind of giving you a visual of what it is we're actually talking about. Cr207 would be an ion that would look something like that. It has 2 chromiums and 7 oxygens all attached. And the whole thing, not each atom, but the whole group, has a collective charge of -2. That's what that means. So that would be an anion. Now, a couple of tricks that you should start out with, first of all. Anions have some patterns involved with them. You can always instantly spot an anion by its name, because the ending of an anion will always be one of 3 things. It will always be IDE, IDE, ITE, ITE, or ATE, 8. Every ion will end, every negative ion, every anion will end with one of those. The cations, in general, will have endings like IUM or GEN. There may be a couple others, but those are the main ones. So that is a general introduction. So now, what about memorizing? Well, whenever you end up taking a test, it's gonna look. There's an example of this 3rd ion quiz. Oh shoot, I shouldn't have shown this. I'll have to fix this and change it next year. I already gave this one this year. It's going to look like this. So this would be the ion quiz for the 3rd group. This is the 3rd group. And so we know that we have to know these. And so, well, that first one shows up. Cyanide is here, so I would have to write the formula, CN, the charge, -1, and there I got credit for that one. But this time I'm not asked the formula, I'm asked the name. It gives the formula already. And so I would write what the formula is. Now that's not on the section 3, but you see that we learned it before, so that it was something that we knew we had to be ready for. Couple of more tricks I'll tell you, then we'll stop this video. There's a whole lot of tricks, but we'll stop with just a couple more. First, one thing to note about cations, if you look at cations like sodium, for example, if we look at sodium over here, sodium in a +1 cation, if we look and find it on the sheet, you'll see that its name is sodium. Wow, big deal. Well, what about cesium? If we look at cesium, it's over here. Well, it's also cesium. But negative ions, anions, are different. If we look at chloride, Cl, if we go find Cl on the sheet, on the periodic table, here it is, we see that its name is not chloride, it's ene, chlorine, and you probably knew that already. You've heard of chlorine. And so the ending changed. So what I tell the kids is, if the ending changes, it's kind of like negative. Anions are like women who change their name when they get married. Because they change the ending. The ending changes. You don't change your first name, change your last name. Not that you have to do that, but it's kind of how it works a lot of the time, and so that's a nice little way to remember that. So if I have a negative ion, if I have Cl-, I'm not going to write chlorine because I know the ending has to change because it's negative. I'm going to write chloride. If calcium is a +1, I have to write its name. I'm just going to write calcium because the pluses don't change. And the last trick that I'll tell you today is a really useful one. Charges. There are some patterns from the periodic table with regard to charge. If an atom is monatomic, and that means there's only one of them, so this would work for calcium, that's monatomic, there's just one atom there, +2 charge but only one atom. Or say bromide would be a monatomic atom. Examples of things that are not monatomic, nitrate. Notice there's 3 O's and an N. That is more than one, and we call that polyatomic, so that would not fit this trick. So monatomic, this trick only works for monatomic ions, ions that only have one atom in them. And the trick is this. If we get to an atom like that, we say, for example, that magnesium, Mg+, or let's say we have magnesium on an ion quiz. If we go look up magnesium on the sheet, we'll find it here. And by the way, yes, you can use your periodic table when you're taking an ion quiz. Turns out that magnesium's charge is +2 and is always +2 because it is in the second group. And anything in the first group has a +1 charge. That is always true. So if you see rubidium on ion quiz, you're going to put +1. If you see strontium, you're going to put +2. Now these middle groups here, they don't have any tricks. There's no tricks there, so we can't learn any tricks. So what we'll do is skip over here to some things we do have tricks for. We have tricks for these three groups as well. This group is -3, -2, and -1. This group will not be on any ions. So you can kind of, these will never come up on ions because they don't form ions. They're always neutral. They don't ever form a charge. So we can kind of ignore that. Think of that as the invisible group. And if we can do that, then we remember it's just +1, +2. And if we start from this side, it's -1, -2, -3. Now, the last thing you might say is, well, what happened to the +3? Well, +3 sort of jumped the gap. This group right here is actually +3. And this group, kind of like these guys, doesn't have a special trick. And in fact, they don't come up as monatomics ever, so we will not worry about those. So those are your tricks for some general tricks for ion quizzes, some things to know about those. And if you get all of that down pat, there's probably about 25 ions or so that you won't ever have to memorize. You just kind of know them from those tricks.